Okay, in this video, I'm going to show you how to derive the formula for the cosine between two angles using dot products. So we know from before, we talked about this in class, that if we have two vectors, v and w, that the cosine of the angle between them is given by the dot product of v and w divided by their respective lengths. So if here is v and here is w, and this angle thing between them, here's the formula for it. And so I just stated this as given in class. I didn't drive it. We worked out some small examples to show why it's reasonable. But I want to, in this video, show you how to prove that. And so the way that we can do that is with the law of cosines. Of course, you could wonder where the law of cosines comes from. I'm not going to drive the law of cosines. We'll take it as given. But just to recall from your high school trigonometry class that let me try to make something that's clearly not a right triangle, because we don't want to, the Pythagorean theorem is a special case here. So if we have some angle theta with legs next to theta of a and b and a third side c, the law of cosines tells us that c squared is equal to a squared plus b squared minus 2ab cosine theta. And so I'll just point out here that if theta is 90 degrees, pi over 2, cosine theta is 0. And so then we just get the Pythagorean theorem that c squared is a squared plus b squared. And so what we're going to do is that we're going to apply the law of cosines to the triangle that is spanned by, here is v and here is w. And so then this third side is going to be v minus w. So we're going to identify a with this vector, b with this vector, c with v minus w here. And so what that says is that, let me get a new piece of paper here all set up so I can write at the bottom. So c squared, well, remember c here is a length, it's the length of v minus w. So that's going to be the length of v minus w. All of that squared is equal to, so we're identifying a with the length of v. So that's the length of v quantity squared. We're identifying b with the length of w. So the length of w quantity squared minus 2 times the length of v times the length of w times cosine theta. So the only thing I've done here is that I'm just copying this formula down here, where c is the length of v minus w, a is the length of v, and b is the length of w. So we have this formula right here, and now our job is going to be manipulate it. We're going to manipulate this until we end up with something that looks like this right here. So how do we do that? Well, we start off with, the important thing is going to be this left-hand side, the magnitude of v minus w, all of that squared. So the magnitude of v minus w, quantity squared, so the square root of magnitude, square root of length, is just the dot product of that with itself. So it's v minus w dotted with v minus w. We can distribute that out to say that is v dot v minus v dot w minus w dot v minus w dot w. And then we end up seeing here that, that should be a plus there, of course. V dot w and w dot v, commutative law. says that those are the same. So this is really v dot v minus 2v dot w plus w dot w. So we have this expression is equal to this expression. And so we asked ourselves, what cancels here? Well, what cancels here is v dot v is the same as the length of v squared. So those cancel out. W dot w, length of w squared, those go away. And so we see that we end up with minus 2 v dot w is equal to minus 2 magnitude of v, magnitude of w, cosine theta. We now again ask what cancels. We see those minus 2 cancels. And to finish this off, we divide both sides by the length of v and the length of w. So those cancel, and we see we are left with v dot w over the length of v times the length of w is equal to cosine theta, which is exactly the formula that we presented in class.